Hi everyone, today we have some 1D kinematics questions for AP Physics 1 that'll test your knowledge with the kinematics equations on the reference table as well as some of the graph questions. The AP is coming up soon, so let's get started. Question 1 asks, a ball is launched upward from a platform 20 meters above the ground with an initial velocity of 15 meters per second. Let's start with part A. How high does the ball rise above the ground at its peak? Let's draw this out. So we have our platform that's 20 meters above the ground. We have our ball on top of the platform that is shot up with an initial velocity of 15 meters per second. For this problem, let's define the positive direction as up. Okay, part A is asking for the maximum distance above the ground that the ball reaches during its trajectory. For this problem, we're going to use this equation. V squared equals VO squared plus 2AD. Let's start by isolating displacement. We'll subtract over V naught squared and then divide by 2A on both sides. Now we can plug in, but before that, we can cross out V squared because at the top of its trajectory, the ball has no velocity in the y direction. So we can plug in 15 for V naught and plug in negative 9.8 meters per second squared for the acceleration, as we have defined downwards as the negative direction. And this gives us 11.48 meters. But this is not the answer to the question because it's asking how high the ball rises above the ground. So remember, the platform is 20 meters tall, so we add 20 to 11.48 and get 31.48 meters. Perfect. Let's move on to part B. It's asking for how long is the ball in the air before it reaches the ground? So, T total, and for this part, we're going to use this equation. D equals V naught T plus 1/2 AT squared. We can begin by plugging in negative 20 for the displacement because the ball will end up 20 meters below where it originally started. Our initial velocity is 15 meters per second times the time plus 1/2 negative 9.8 meters per second squared for our acceleration times t squared. This gives us negative 20 is equal to 15t minus 4.9 t squared. And then we can rewrite this as our final quadratic, 4.9 t squared plus 15t, and add 20 to the other side. Now, we can use the quadratic equation to get our t values. T equals negative 15 plus or minus the square root of 15 squared minus 4 times 4.9 times 20, all over 2a, or 2 times negative 4.9. Putting this into our calculator, we get t equals negative 1 and t is equal to 4.06. Now it doesn't make sense that t could be negative 1 because time cannot be negative. So we end up with t is equal to 4.06 seconds. Let's move on to part C. What is the velocity of the ball as it hits the ground? We can simply use this equation. V equals V naught plus AT. We can plug in 15 for our initial velocity, negative 9.8 meters per second squared for acceleration, and we can use our answer in part B for the time, 4.06. When we put it in our calculator, we get negative 24.79 meters per second. Okay, let's move on to question 2. For question 2, we're given the following graph. Based on the velocity versus time graph provided, what is the object's velocity at t equals 6 seconds? Part A is very simple. Since we're given the velocity on the y-axis, all we have to do is trace it from time at 6 seconds, which gives us 6 meters per second. Okay, part B asks, what is the object's acceleration at t equals 4 seconds? To find acceleration, we'll have to review some of our equations. We know that acceleration is equal to velocity over time, or in other words, the change in velocity over the change in time. This is our slope, so we can pick 2 points on this graph, find the difference in the y values and the x values, and divide y by x. So let's pick this point at t equals 6 and this point at t equals 2, because the slope between these 2 points is the same throughout. So the velocity at t equals 6 is 6, and at t equals 2 is 2. And for time, it's 6 minus 2. We have this point 6, 6, and this point 2, 2, which equals 4 over 4, or just 1. So the acceleration at t equals 4 is simply 1 meter per second squared. Part C asks for the total displacement of the object after 8 seconds. If we review our equations, we can remember that d is equal to vt. So this means that the displacement is equal to the area under the velocity versus time graph. So we can do that by simply dividing up this graph into familiar shapes and finding the areas of them. Let's start with this little piece right here. The area of the square is simply 2 times 2, which is 4. Next, we can divide up this shape and find the area of this rectangle and the triangle. The length of the rectangle is 4, since it's 6 minus 2, times 2, which is the height, which equals 8. This triangle has a width of 4 and a height of 4, but we have to divide by 2, which gives us 8. And then finally, this last triangle here, the height is 6 times the width of 2 divided by 2, which gives us 6. Adding these all up, we have 4 plus 8 plus 8 plus 6, which equals 26 meters. So the displacement after 8 seconds, assuming the initial position is x equals 0, is 26 meters. Okay, let's move on to question 3. For our final question, we have a car traveling at a constant speed of 20 meters per second passes a stationary motorcycle. 2 seconds later, the motorcycle starts from rest and accelerates uniformly at 4 meters per second squared to catch up to the car. Let's begin with part A. How long after the car passes the motorcycle will the motorcycle catch up? Let's draw this first. We have a car that travels at a uniform 20 meters per second, that passes a motorcycle that is initially at rest but accelerates at 4 meters per second squared 2 seconds after the car passes it. Okay. For this problem, we're going to write the displacement equations for both the car and the motorcycle, set them equal to each other, and solve for time. So the displacement equation for the car is simply vt, since it has uniform velocity, which is equal to 20t. The distance equation for the motorcycle is v0t plus 1/2 at squared. We can get rid of v0t because the motorcycle has no initial velocity. So we can rewrite this as dm equals 1/2, plug in for acceleration, which is 4 meters per second squared, times t minus 2 squared. We have to subtract 2 from t because we have to account for the motorcycle starting 2 seconds after the car passes it. Since the distances should be the same when the motorcycle catches up to the car, we can set these two equal to each other. So 20t is equal to 1/2 4 times t minus 2 squared. We can simplify this a bit. And we can solve for t now. Let's divide by 2 first and get 10t is equal to t minus 2 squared. We can expand the right side and then subtract 10t from both sides to get a quadratic. So t squared minus 14t plus 4. Now we can find t by using the quadratic formula. So t is equal to 14 plus or minus the square root of negative 14 squared minus 4 times 1 times 4 over 2 times 1. If we put this into our calculator, we get that t is equal to 0.29 and t is equal to 13.71. It doesn't make sense that t could be 0.29 because the motorcycle doesn't even start moving until 2 seconds after the car passes it, so t has to be at least 2 in this problem. So for part A, we have t is equal to 13.71 seconds. Let's move on to part B. What distance does each vehicle travel in that time? We can solve this problem by simply using the car equation for distance. So d equals vt, which is 20 meters per second times 13.71 seconds, which is equal to 274.2 meters. If you have any questions, please leave a comment, or if you have any specific problems you'd like me to cover, you can also comment them below. And thank you for watching.